the last one we're going to look at is based around altitudes. So, an altitude, we also call it the height. So, if you have any triangle, yeah, any triangle here, you go from the vertex to the other side and you do it perpendicular. And that is what you have there as your altitude. Now, it's important that it's perpendicular, but this is different from the perpendicular bisector, you'll notice, because it doesn't bisect the other half. You can see that quite clearly. One side is about 1 unit long, the other side is 4 units long. So it's not bisected, it's just perpendicular. Um, with this, the only thing you have to kind of worry about sometimes is if you're trying to find the altitude of a vertex and it happens to be not above the triangle, like I want to drop it down perpendicular to the opposite side, it's just there's no side there to run into, right? We basically have to draw a little extended line out there to kind of see where it would be perpendicular. So do keep that in mind there. But when you are doing this, the three altitudes will have a point of concurrency, just like all the other pieces will so far. And that point of concurrency is called the orthocenter. Ortho is just kind of a fancy way of saying perpendicular. Like commonly people talk about, oh yeah, the two walls of my house are perpendicular. That's how contractors do it. Mathematically, we talk about them being orthogonal because they're in more than two planes. Um, and the only reason why we do that is because there's math for describing things about eight spatial dimensions. How do you say two things are perpendicular in that? Well, you can't draw a picture of it because your brain can only think of 3 dimensions. So we have ways to calculate out some whether or not things are orthogonal in other ones. But it's basically a fancy word for perpendicular. Um, but the orthocenter is going to be the intersection of all the altitudes. Um, and this is the one that's kind of sad. It doesn't have anything extra like the centroid cut the medians into a third and 2/3. The incenter made it so that you could find the radius of a circle inscribed in the circle. The circumcenter found the radius of a, a circle that it circumscribes on the outside of a triangle. The orthocenter is just kind of there. It's a thing. It doesn't have anything special really for it. Um, let's go ahead and find an orthocenter. All right. So I need myself some axes here. And this one thankfully doesn't have to be as big as the last one. That should be plenty to work with there. So I'm going to plot the 3 points of the triangle. F is -2, +4. 1, 2, 3, 4. There's my F. G is +4, +4. And this that I see right here is I just made a horizontal line. Oh, thank you so much for that, because I know any line that's perpendicular to that horizontal line is going to be a vertical line. Makes my life so much easier. And H, it's 1, -2. So we'll go to 1 and then down to -2. And dang, for H here, we're going to have to do some calculations. So let me draw my triangle out. So there is my triangle. Now, if I want to find the coordinates of the orthocenter, I have to find some altitudes. So I have to look for a vertex, the opposite side, and I have to find a perpendicular line, right? So here I take the slope of the opposite side. Here the slope is 0, which means the perpendicular line is going to have an undefined slope through vertex H. So since it's horizontal, it's going to be a vertical line. And if I ever see one of these, oh, you know, I've been doing my altitudes in green. I can just draw it real quick there. And that's nice. It's really nice to handle right there. The problem is when I get to another altitude, I have to pick another point. Let's pick G. Doesn't really matter. G. And the side opposite from it is FH. So I need to find the slope of FH. Well, there are two ways of doing it, of course. There's the slope formula. That is going to be negative 2 minus negative 2 minus 4 over 1 minus negative 2, or negative 6 over 1, right? Does that seem right? No, that's plus over 3. So that's negative 2 is my slope, which means for the perpendicular line, I have to take the opposite reciprocal of that slope and change it to positive 1/2. But once I have the slope of positive 1/2, so slope 1/2 through point G. Now I could write the equation out for this, but I've already got it all drawn out. So all I'm going to do is go to point G and count off my slope of 1/2. So I'll go up 1 over 2, or down 1 to the left 2, down 1 to the left 2, down 1 to the left 2. And if you take a look at this line that I draw from G through those points I just counted out, what's left over is perpendicular as well. And you take a look here, see where those two lines intersect. Now this is the only part where you might need an equation. I need to see where two lines intersect. And last time when we were working on this intro, it was nice. It was on a point. I could just graph it. It's fine. And this one looks like it should be at a halfway point. It looks like that orthocenter is at 1, 2.5. But how do I know for sure? I have to solve the system of equations. Now, what's nice is I can find that pretty easily. For the vertical line, that equation is x equals 1. So there's one equation. For the other line, the altitude through G, it has a slope of 1/2, and it goes through the point G, so it's y minus 4 equals 1/2 x minus 4. So y minus 4 equals 1/2 x minus 2, add 4 to both sides, so I get y equals 1/2 x plus 2. And now all I have to do is take those two equations and see where they intersect. Thankfully, because I have a vertical, it's easier to do, and I don't have to do substitution or elimination or any of that kind of stuff. All I have to do is plug in 1 into this function here. Y equals 1/2 times 1 plus 2, and look at that, it's 2.5. So this is our orthocenter. But what's happening with this is you're finding two perpendicular lines and their intersection. That one can be really quick and easy like this, or it can take you longer because you use the point slope form for two different lines. But if you can never get a vertical or a horizontal out of there, use that as one of the lines.